Okay, so there are two types of reactions that we can have for acid-base reactions, and the most popular one, and the one that is covered in this chapter, is neutralization reactions. And there's a reason why they're called neutralization reactions. So we have, in this case, let's say, we'll do NaOH aqueous plus HCl aqueous. So we have NaOH is a strong base. HCl is a strong acid. And so this solution, so imagine that we actually have a solution. So this is our base. So we got NaOH, NaOH. So this has a pH that is much greater than 7. And the strong acid has, so this is HCl, has a pH much less than 7. So when we add these together to make a new solution, the pH, so what will the pH be? And so if we look at this, we add these together, we will basically create water, H2O, as a liquid plus NaCl aqueous. Now, we know that this is actually just Na plus ions and Cl minus ions floating around, but we write that as NaCl aqueous in this notation. And so you'll notice that in terms of pH, the water has a pH of 7, and that NaCl, the ions, do not react with water, are not acids from bases, so they do not affect the pH. So the reason why it's called a neutralization reaction is that you take two pHs that are not neutral, one greater than 7 for the base, the less than 7 for the acid, and you create a solution that has a pH that is neutral, or 7. So this is neutral. Neutral pH. And so that happens when you react a strong acid and a strong base. So we can also have, so I guess I want to point out here is that when we're writing neutralization reactions, that when we write NaOH and HCl, we can actually write them in the way they're actually formed. So if I were to look at the solution, or these different color, if we write the solution, what I actually have is Na plus ions and OH minus ions. And here I have H3O plus ions and Cl minus ions. And so we can write that out. We can say, okay, well, what do we have? We have, instead of having, so I'll rewrite this so we can see it. NaOH plus HCl, both are aqueous. But we can write these out as ions and say we have Na plus aqueous plus Cl minus aqueous plus H3O plus aqueous plus Cl minus aqueous. Now, if you here put H plus instead of H3O plus, that's fine. That's not, you're basically saying the same thing. And then what's going to happen is we look at what can happen here. Oh, I'm sorry. I didn't mean a Cl minus. I meant an OH minus. So this is OH minus aqueous. And so what we have is these OH and H3O plus will form two waters. And those will be liquids, plus the Na plus Cl minus, both aqueous, will not do anything. And so, again, this is our overall equation. So we call this this equation, we'll box this. This is our overall ionic equation. Sometimes we call this the net ionic equation. Not net ionic, sorry, not net. Definitely not net. The total ionic equation includes all. So total ionic because it includes all of the ions in the solution. But you'll notice that we have, in this particular reaction, we have the same thing, Na plus and Cl minus on both the reactants and product sides. And so they're not really providing information, not really doing anything, so we can cross those out and we can get our net ionic equation. That's basically just the things that react. So our net ionic equation is equal to OH minus plus H3O plus goes to form 2H2O liquid. And this is the net ionic equation. This is actually showing you what's happening. And so what do we call these ions? So the things that cross out, I guess we'll do it in purple because we crossed them out in purple, are called spectator ions. That would be the Na plus and Cl minus, because they did no chemistry in this reaction. They didn't react. They were just simply watching other things react. Okay, and so this idea of total ionic equation or net ionic equation, we're going to see this again for other types of aqueous reactions, specifically looking at when a precipitate is formed in a reaction, looking at solubility of ions in solution.